Figure shows three blocks A, B, C and spring system. The spring constant of two springs are K and K respectively. Now we have to find the following things. When the system is in equilibrium, find the tensions at different places. And what happens when spring between block A and ceiling is cut? What happens when string between block A and block B is cut? And what happens when spring between block B and block C is cut? Now let us see when the system is in equilibrium. For block C, suppose the extension in spring above block C is x2. Since block C is in equilibrium, so we can write Kx2 equal to mg, where x2 is extension in spring C. Until and unless spring do not cut, it behaves as a string. So, for block B, we can write the free body diagram like this. Suppose tension in string connected between two blocks, each of mass small m, is T. So for equilibrium of block B, we can write T equal to mg plus Kx2. Since Kx2 equal to mg, so T equal to 2mg. Now, for equilibrium of block B, we can write Kx1 equal to T plus mg, where x1 is the extension in the spring connected between block A and ceiling. Since T equal to 2mg, so Kx1 equal to 3mg. So these are the values of Kx1, T and Kx2. Kx1 equal to 3mg, T equal to 2mg and Kx2 equal to mg. Now let us see what happens when spring between block A and ceiling is cut. When spring between block A and C is cut, Kx1 will disappear. Kx1 will disappear, and block C will have zero acceleration because spring have the property that spring can't change its behavior instantaneously. Spring cannot change its behavior instantaneously, so acceleration of block C will be equal to 0. Now, for free body diagram of block A, we will get T plus mg equal to m into acceleration of block A, that is AA. And for block B, we can write Kx2 plus mg minus T equal to MAB. After solving these equations, we will find acceleration of A and B to be equal to 3g by 2. Now, let us see what happens when string between block A and block B is cut. String have the property that when it is cut, tension in string becomes 0 at the same instant. Now, make the free body diagram for block A and block B. Since string is cut between block A and block B, so here acceleration of block C will again be equal to 0 and equation for block B will be equal to kx2 plus mg equal to MAB, and equation for block A will be equal to kx1 minus mg equal to MA. Equation for block A is kx1 minus mg equal to m into A, where acceleration of A is vertically upward. Equation for block B is kx2 plus mg equal to MAB, where AB is acceleration of block B in downward direction. After solving these equations by putting kx1 equal to 3mg and kx2 equal to mg, we will find acceleration of A and B to be 2g. Acceleration of A is 2g upward and acceleration of B is 2g downward. Now let us see the case when spring between block B and block C is cut. When spring between block B and block C is cut, the block C will fall freely by acceleration due to gravity. So acceleration of block C will be equal to g. Now here, since spring between block B and block C is cut, so kx2 will get disappear. Now make the free body diagram for block A and block B. For block A, kx1 minus mg minus t equal to m into A. For block B, t minus mg equal to m into AB. After solving these equations, we will get A equal to g by 2.